Welcome back to Vuln Vibes. In this deep dive, we are going to talk about a truly critical XXE chain impacting Apache Tika. And if you're running any kind of enterprise content ingestion pipeline, you know Tika. It's often that tireless workhorse, right?
Absolutely. It's everywhere.
Normalizing, extracting metadata from just this endless stream of files.
Yeah.
And that means this specific vulnerability chain is sitting, well, right at the front door of your data stack.
Right at the perimeter.
Our mission today, it goes far beyond just a simple CVE summary. We're not just confirming the severity of this XML External Entity injection flaw.
Yeah.
We're diving into the, let's say, the architectural and the patching nuances, those crucial scope expansion details that really turned remediation into an operational nightmare for a lot of security teams.
It did. And, you know, these nuances are the real difference between thinking you're patched and actually being secure.
Exactly.
And this is just a mandatory deep dive for anyone dealing with modern software composition analysis. I mean, when we classify a vulnerability as critical in a parser like Tika,
which is so ubiquitous.
right, it's because the exploitation context is, well, it's low effort, and the payoff for the attacker is massive. Tika is designed to handle complexity. But that complexity, as we'll see, is precisely what got weaponized here.
So understanding the dependency matrix isn't just optional.
No, it's paramount to survival when you're dealing with file ingestion.
Okay, so let's start where every good deep dive does, the anatomy of the attack. For our listeners, we're talking about classic XXE.
The classic flaw, yeah. It fundamentally allows an attacker to manipulate XML processing to, reference external entity.
Which leads to unauthorized file access, network activity, all the bad stuff.
Exactly. In a typical Tika deployment, we are talking about turning a simple file upload into a way to exfiltrate system files. Or even worse, conduct server-side request forgery SSRF.
And just think about the Tika environment for a second. It's often running with pretty significant permissions to access and index data.
Right. So if an attacker can leverage an XXE to read files, they aren't just reading benign logs. They're going after config files, environment variables, maybe even AWS credential files if the system is misconfigured.
And the SSRF angle is just as terrifying in this context.
No, it is.
I mean, if Tika is processing documents on a server, that server has an internal view of the network.
It's a trusted insider.
It can see internal APIs, admin consoles, metadata services, things that are shielded from the outside world. An attacker executing SSRF through a doc parser is essentially using your own system as a pivot point.
The risk profile is just astronomical, and the sophistication of the vector only makes it worse. This isn't just, feeding some simple malicious XML to an API.
Okay, so here's where it gets really interesting. Let's talk about that file format complexity.
So the vulnerability isn't in the PDF standard itself, but in a specific feature embedded within it. The injection is carried out with a crafted XFA file. That's XML forms architecture.
Right, which is used for interactive forms inside PDFs, a legitimate thing.
A totally legitimate thing. But this XFA payload is then maliciously nested deep inside the PDF document structure.
So the attacker is weaponizing a recognized feature. The PDF itself might look fine to a casual observer, maybe even some superficial tools.
For sure. But Tika's parser, when it goes deep and hits that nested XFA structure, that's when it attempts to process the malicious XML.
It's a bypass mechanism, really. It's designed to defeat perimeter security that's just looking at file magic numbers or doing simple sanitization.
Exactly. By embedding the payload, the attacker ensures that the complex internal parser logic, the very thing Tika is built to do, becomes the point of failure.
And we should be crystal clear on the timeline here. This deep dive is about the expanded scope and the patching headache. But we're addressing the same underlying flaw from CVE-2025-66516. We're here to talk about why the initial fix guidance just wasn't enough.
That's the critical pivot point, because when remediation is complex, compliance tends to be low. We have to map the full affected surface area, that whole dependency matrix, with surgical precision.
Okay, so for the teams out there, deep in their vulnerability scanning and dependency tracking, what artifact IDs should they be hunting for?
We've got 3 key ones, and they cover Tika's entire life cycle, really. First, and this is arguably the most important, is the foundation. tika-core.
The core library.
The org.apache.tika.tika-core package.
Right, yeah.
And this is critical because it spans a huge operational window, affecting versions from 1.13 all the way through 3.2.1.
That's a massive range, years of releases.
It is. If you're running Tika, you likely have a vulnerable core dependency somewhere.
So what about the immediate entry point, the thing people probably notice first?
For Tika 2.x and 3.x, that was the tika-parser PDF-module. The artifact is org.apache.tika.tika-parser-pdf-module, vulnerable in versions 2.0 through 3.2.1.
So that's the component that actually reads the PDF.
Yep. And then finally, we have the ghost in the machine, the legacy path. This is for the Tika 1.x branch, which, believe it or not, a lot of enterprise systems still rely on.
Oh, for sure.
In that world, the functionality was more monolithic, tied up in the tika-parsers module. So that's org.apache.tika.tika-parsers. This affects versions 1.13 up to 1.28.5.
That kind of sprawl is just the worst kind of vulnerability management headache.
It really is.
You've got 3 different artifact IDs to check for, depending on whether you're on legacy Tika 1, modern Tika 2, or 3, and how you integrated the parser.
Yeah.
It just fundamentally complicates your SBOM analysis.
Yeah.
If your scanner just flags the artifact ID, you need manual checks to be sure you're hitting the right version across all those paths.
And that sprawl of versions is already a problem.
But let's get to the real frustration point, the specific architectural gotchas that cause so many teams to fail their first remediation attempts.
The reason we're doing this deep dive?
Right. This is a case study in modern supply chain risk. It shows how a bug can be, well, architecturally decoupled from the interface you think it's in. So nuance 1, the core dependency issue.
Okay.
While the PDF module, the tika-parser PDF module, was the reported entry point, the vulnerability itself, and crucially, the fix for it. It resided in tika-core.
Wait, so the front door for the attack was component A, but the lock to prevent it was housed in component B.
That's a perfect way to put it, yes.
So why? Why does that architectural separation even exist? What does that say about Tika's design?
Well, it suggests that core XML processing and its security defaults were centralized in tika-core. This is often done for consistency, right? So PDF, EP, DOCX, anything with XML gets the same security policy.
The intention is good then. One place to manage security.
The intention is good, but the implementation becomes a real hazard for remediation.
So if a security team was using their standard vulnerability reporting tools and they saw a flag on tika-parser PDF module and they just patched that one module,
They would still be critically vulnerable.
wow.
They've replaced the component that calls the logic, but the underlying logic itself, which is in the unpatched tika-core, still contains the vulnerable settings.
So this is the key takeaway. Upgrading the parser module, but failing to upgrade tika-core to version 3.2.2 or higher. It's classic shallow patching.
It is. You closed the screen door, but left the main door wide open.
Exactly. And we've seen this play out time and again in modern Java ecosystems. When a functional component relies on shared core infrastructure, the fix has to happen at that lowest shared level. If you don't update the library that handles the XML inside the PDF, you've done nothing.
That level of detail is critical, and it leads us straight into the second operational landmine here, the Tika 1.x legacy oversight.
Right. The initial report was very focused on the modern, modular Tika 2.x and 3.x structure.
But it missed the old stuff.
It failed to rigorously account for Tika 1.x releases, which are still heavily relied upon in older indexing and data migration platforms.
So for our listeners still running that 1.x branch, and that's probably a lot of you, where was the PDF parser located back then?
In the 1.x architecture, it wasn't modular. It was just baked into the big monolithic org.apache.tika.tika-parsers module.
So a security team on Tika 1.x could have easily read the patch notes, seen references to the new modular parser, and just assumed.
And wrongly assumed.
That they were not affected.
Exactly. The documentation didn't initially spell out the same core XML logic vulnerability also lived inside that massive 1.x tika-parsers bundle.
Which means the blast radius just automatically included all these legacy deployments, running the entire 1.x branch up to 1.28.5.
It did, and the patching requirement there forces a really tough choice. Either you upgrade the entire tika-parsers module, which is a heavy lift with potential API changes, or you start the painful process of migrating off the 1.x branch entirely.
A huge architectural undertaking.
This whole scenario just demands a conversation about defense in depth beyond patching.
Like what?
Well, if Tika is running in a low-privilege container, the impact is severely limited. Teams should be running it in heavily restricted, isolated environments.
No access to sensitive files, no ability to make outbound network calls.
Right. No network egress.
Right.
That alone neuters the SSRF threat.
Absolutely essential for any component handling untrusted input. But even with those measures, a critical patching failure leaves a hole. So if we connect this all back to the bigger picture, this scenario it encapsulates the full complexity of securing modern software supply chains.
It really does.
The attack vector is technically sophisticated, this nested XFA and PDF, and the remediation is architecturally complex. The functional component is decoupled from the security component. It's a perfect storm.
It is. And this isn't just a lesson about Tika. It's about how modern software composition makes true vulnerability assessment a job that requires architectural insight, not just looking at a manifest.
You have to trace the actual flow.
You have to trace the flow of execution and confirm where the corrective code actually landed. Otherwise, you'll fail.
Okay, let's recap the critical findings for you, the listener. We're dealing with a critical XXE using a crafted XFA in PDF vector. That allows for system file exfiltration and SSRF. And the true danger is in the complexity of the fixed location. Remediation is not trivial. Patching the immediate entry point, the PDF module, was not enough.
Not enough.
You have to confirm that tika-core is upgraded to 3.2.2 or higher, or that you've addressed the vulnerability in the legacy tika-parsers module if you're still on the 1.x branch.
This whole thing should be a mandatory training scenario. It just perfectly illustrates the danger of shallow patching and the cost of neglecting dependency mapping.
Right.
If you just rely on high-level automated reports without verifying that the fundamental component holding the core logic is updated, you are leaving the door ajar.
Verify your patches, verify your dependency trees.
You have to.
Which raises an important final question for you, the listener, to consider. Given the sheer sprawling complexity of file formats like PDF and all the other parsing libraries out there, think POI, iText, others.
Yeah, there are tons of them.
What assurance do you have that similar unaccounted for XXE vulnerabilities aren't hiding deep within their core dependencies, just waiting for a sophisticated nested payload to exploit that same architectural decoupling?
That's the real question. The lessons from Tika extend to every document ingestion pipeline. The next critical flaw probably won't be a simple top-level manifest issue.
No, it'll be hidden deeper.
It will be hidden deep in the core logic, requiring a full architectural trace to find and to fix. You have to audit your ingestion pipelines for that implicit trust in file structures. Assume that complexity equals risk.
Audit your dependency trees, verify your tika-core versions, and never, ever assume the component with the bug is the component with the fix. Thanks for joining us on this deep dive.